Thank you so much for joining Nicole and I this Thursday afternoon. This is our very last lesson in the course on functions and inverses. And of course, I'm really pleased to have my fabulous TA, Nicole, here with me. So thank you so much, Nicole, for everything that you do for me and for the students. So what I wanted to do in this lesson was have a look at some exam type questions. I mean, we did in the last lesson as well. We also looked at some exam type questions, but these are ones that are sort of slightly more difficult. So I thought it would be a good idea for us to work our way through those. Yeah, so I've tried to find things that are a little bit more challenging, perhaps maybe a little bit unusual, that sort of stuff. All of these questions come out of NEC papers. Okay, so the idea is to provide you with relevant information and questions. Okay, all right, let's get started. The very first question, hopefully this is big enough, gives us two graphs, f of x equals minus x plus 3 and g of x, which is log 2x. And the first thing that they ask us to do is to sketch these graphs on the same set of axes. Okay, so the first one, f of x, is a straight line, super easy. The second one, g of x, is a log function, and hopefully if you've learned your log functions and your log rules and all that kind of stuff, you know exactly what it is that you're supposed to be sketching. So in this case here, g of x, okay, is going to be the inverse of g of x. I'm just pointing this out to you, not that they've asked us to sketch this, they haven't, is this. So we're drawing the inverse of that. Okay, so hopefully you know what shape it is. It's an increasing function, blah, 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 blah. All right, let me just, oh, hang on a second. I didn't set this out. Sorry, these are all the questions I wanted us to do this evening. Let me just move everything down. Sorry, I should have done this earlier. There we go. Okay, so let's sketch them. Now, when they ask you to sketch a graph or graphs, Matrix, they really don't want you to spend 10 years on constructing a set of axes and labeling every integer and whatever. Honestly, you just need to draw yourself a set of axes. Okay, like I am over here. And the only thing that you need to label are the intercepts with axes or other relevant information. So for example, if you're drawing a cubic function, then you need to label the turning points, the x-intercepts and the y-intercepts. If you're drawing a parabola, you need to label the turning point, the x-intercepts, the y-intercepts. These graphs don't have turning points or any other sorts of things. So it's literally just going to be sketching the graph and then labeling the intercept with axes. Okay, so let's use some different colors. So we'll use orange and we'll draw ourselves the straight line. Okay, so it has a negative gradient. So it's going to look something like that. All right. And we need to obviously work out its x and y intercepts. So you can even do that by inspection at this stage. I mean, if it is the graph f of x equals minus x plus 3, we know that its y-intercept is going to be 3. So we can label that as 0 and 3. And over here, we also know that its x-intercept is going to be 3 and 0. Okay, so literally just by inspection, there would be 2 marks on that. So that would be super easy. And now our log function. All right, so again, if you've learned this, it just makes your life so much easier. So your y-axis is now your asymptote, and it will have an x-intercept. So this graph will look something, I haven't drawn it very well, but it would look something like that. Sorry, come on. Sorry, I don't know where my pen's gone. Sorry, just give me 1 second. My pen seems to have stopped working. I don't know why. How?
Lee, do you think it ran out of ink?
No, it can't. It's a writing pad. So that is so weird. This has never happened before. Oopsie. Oh, now it stopped screen sharing, of course. All right, lovely. Thank you. Oh, the whole thing shut down. Hold on a second. Sorry, guys. I don't know why it's done this, but then I will never understand computers fully. My friend and I always say a classroom full of boys will never make us cry, but computers will. Okay, here we go. Can you see my screen again, Nicole?
Not yet, Lee.
Not yet. Okay, let's try this. How's that? Is that working?
Back in action.
There we go. All right. My apologies. I don't know what happened. Maybe now I can draw this graph a little bit better this time round. Okay. Okay. Not fabulous, but there we go. All right. And it will have no intercept with the y-axis because that is its asymptote. And again, if you've studied this, you could just do it by inspection. The intercept with the x-axis would be at 1 and 0. Okay, so that's what your graph would basically, your two graphs would basically look like. Okay, there would be marks allocated for x and y intercepts, and then that would be for your orange graph, and then for the purple one, the log graph, there would be a mark for shape and a mark for the x-intercept. In fact, I've got the answers over here to the side, so you can have a look at that as well. Not that I want us to look at the answers now, but there you go. See, their shape is a little bit better than mine. That's what I was trying to draw. Okay, so mark on shape that it's increasing, it's x-intercept because there isn't a y-intercept, and then the x and y-intercepts on the straight line. Okay, let's just move that over to the side. Next thing that they want us to do, 6.2, write down the equation of g to the minus 1x, the inverse of g in the form y equals. Okay, so again, if you've studied, this part should be super, super easy. Okay, so here, this should be the graph of, we're doing g to the minus 1 of x. So we've got, semicolons, we need to interchange x and y. So that's going to give us the graph of y equals 2 to the x. Okay. 6.3, now they've asked us, explain how you will use question 6.1 and or 6.2 to solve the equation log 2 3 minus x equals x. Okay, so that's the reason why I chose this question, because there's this really unusual question here. So again, instead of me telling you matrix, what do you think we're going to do here? How do you think we're going to attack this problem? I mean, what does log 2 3 minus x equals x even mean to us? Is there possibly some rearranging that we could do there? How does this relate to what we already have in front of us and what we see? Anyone got any ideas? Remember the last time we were together, I had written this down for you guys, okay? And I'd said to you, log base number equals exponent. Do you remember that? Okay, and I said to you, make sure that you learn this, okay? Because again, this is what's coming up. If you have a look at log base 2 3 minus x equals x, this is exactly what they've given you. So there's your log. So there's the word log. There's your word log. There's the base. Let's do that in a different color. So your base is 2. Your number in this case is 3 minus x equals exponent. There's your exponent. What color should we choose? Orange. Okay, equals exponent. Okay, so now, yeah, we're going to rearrange them to find our exponent. Absolutely. So Johannes, can you tell me how to rearrange it? Now that I've pointed out to you what it is that you're actually looking at, how would we rearrange this? What should I write? Remember the other thing that I showed you guys, all right? Remember when we rewrite this in exponential form, we write it as base exponent equals number. Okay, so this is what they've given us, and that's what they expect us to do. So what's the base here? The base is 2. The exponent is x, and your number that it's equal to is, that's it, 2 to the power of x equals 3, 3 minus x. Well done, Kanyusile, absolutely. And then if you rearrange the order of the terms on the right-hand side, you see 2 to the x equals negative x plus 3. So now that we understand what it is, sorry, this is an x over here, it looks like a 2. So now that we understand what it is that we are looking at, now we can actually go ahead and go and answer the question. I think that's a really clever question myself. That really shows whoever set this question has a very deep and good understanding of logs themselves, which we would expect from an examiner. But yeah, a really, really cool question. So they're asking us how we would use the graph of the inverse and our straight line to find a solution on the Cartesian plane. All right, so what we are doing here is we have to use the inverse of g. So in other words, we have to use g minus 1x and f of x to determine a solution. Okay, that's what the question expects us to be able to do. If we have a look over here in our answers, there we go. So what we would need to do is we would need to reflect the graph G about the line y equals x. So that means to obtain g minus 1 and then determine a point of intersection of f and g to the minus 1. Does that make sense to everybody? Okay, so it's a point of intersection between the inverse and f of x. Okay.
Mom?
Yes, can you see there?
Can I please see the answer? Can I take a screenshot of the answer,
Of
please?
course you can. I'll go straight back there. Just give me 1 second. There we go. Let me just go up. I'll make that a little bit bigger for you. There you go. Okay, so we need to rearrange it. You would have got 2 marks for rearranging it and writing 2 to the x equals minus x to the 3, sorry, minus x plus 3. And then you would have got another mark for saying that you would have had to reflect g over the line y equals x to get g to the minus 1 and then determine the point of intersection of f and g to the minus 1. Okay, is everybody happy with that?
Thank you.
No problem. Okay, and now they want us to write down the solution to this. All right, so now that we've already rearranged it, what they're essentially asking us to do is to determine the solution of 2 to the x equals negative x plus 3. Now, there is a way to do this, and if you study maths at university, they will teach you how to solve for x as an exponent and x as it normally appears to be, but that's beyond the scope of what we're doing here. So the only way that we can do this matrix is by inspection. So the graph 2 to the x would look something like that. And we've now got to figure out where this point of intersection is. So we can see that the point of intersection has to take place in the first quadrant. So we know that x has to be positive. So what value satisfies the left and the right hand side simultaneously. It has to be a positive x value. We have to do this by inspection. Yeah, exactly, Johannes. It's that simple. Okay, so quite right. I mean, not that you would write this, but 2 to the power of 1 is equal to -1 plus 3. Absolutely. Okay, so x would need to be equal to 1. So yeah, that would be done by inspection. Okay.
Ma'am,
Good
can you
job.
repeat the question?
Pardon?
Can you please repeat the question? I'm lost. For 6.4.
Okay, so 6.4, can you see that I wanted you to write down the solution to log base 2, 3 minus x equals x. They wanted you to write down the solution to that. So what balances the left-hand side and the right-hand side? So essentially what they're asking you to solve is what I've written here in blue.
Mm-hmm.
But we don't solve these sorts of equations in caps, right? So the way that they want us to do it is by inspection, not algebraically.
Okay.
All right, so we're looking at it and we're saying to ourselves, well, we know this point of intersection is in the first quadrant. So that must be where x is a positive number. So we're going to look at it and we're going to inspect the equation. We're going to say to ourselves, well, what does x need to be so that the left-hand side and the right-hand side balance one another? Johannes said 1, and he's quite right. It is 1. Okay.
Thank you, ma'am.
All right, it's a pleasure. Okay, Matrix, so if everybody's okay with that, we can move on to the next question. Are there any questions? Are we all good? Okay, cool, let's move on. All right, now the second question that I'm going to do with you is this one on the parabola, because it's also got some inverse questions to it. So what they've given us here is a parabola, f of x equals -2x squared plus 4x plus 16. And they've given us the straight line, g of x equals 2x plus 4. And they've told us that a and b are the x-intercepts of f, and c is the turning point of f. And the first thing that they want us to do is calculate the coordinates of A and B. Now, I think that the first 3 questions you guys are more than capable of doing on your own. So what I thought I would do here is give you a little bit of quiet time, maybe 5 minutes, and you guys can work that out. All right, so the first 3 questions, 5.1, 5.2, 5.3, go for it. We'll mark our answers and then we'll go on to 5.4 together. There we go. Now you guys should be able to see that a little bit better. You guys finished? Thanks, Kanisile. Cool, Thelma. Well done. How's everyone else doing? So I see Canisila's posted a couple of answers. Thelma says she's done. Everybody else ready? Or am I chasing you? Thanks, Michelle. Thank you, Lucidi. Okay, nice. All right, lovely. Thanks, Johannes. Okay. All right, so as I had said, we would just do the first 3 questions. All right, so when you want to calculate the coordinates of A and B, those are the x-intercepts where y is equal to 0. So there would be 1 mark for taking f of x and letting it equal 0. I'm going to grab the answers for you. Here they are. Just move them down here. Okay, so just have a look and see what they give you marks for here. So the first mark is for making f of x equal to 0. No, sorry, I'm talking nonsense. You don't even get a mark for that. Mark for the factors. Okay, so be careful, matrix. When you factorize, what happens a lot of the time is that you leave off this equals 0. And then they mark you down for that. So if you are factorizing to solve, make sure it equals 0, and then 1 mark on 4 and 1 mark on -2. So your answers were correct as far as A and B were concerned. Kanyesile, well done for that. Then in question 5.2, the coordinates of the turning point. So the easiest thing for you to do, because it was given to you in standard form, is to use that formula x equals -b over 2a. So that's what they've done over here. They've subbed into x equals -b over 2a. So b being the coefficient of x and a being the coefficient of x squared. And then they've discovered that that would be 1, and then they've taken 1 and they've calculated f of 1. Okay, and they've got the coordinates at C to be 1 and 18. How's everybody doing so far? Did you guys also get that?
Yes, ma'am.
Good, Cassandra. All right, everybody else managing. Cool, Bootley. All right, nice, Michelle. Okay, so yeah, those are grade 11 questions. They're not supposed to be difficult. And then the last one would be the range. So depending on how you choose to write it, you could have either written it as y is smaller than or equal to 18, or you could have written it with interval notation. So y is an element of round bracket -infinity to 18 with a hard or square bracket. Okay, so everybody happy with that? We can get those out the way and we can carry on. Let me just move it over here to the side. Now that's out the way. Okay, let's get that out the way as well. All right, next question is 5.4. So what I'm going to do is I'm just going to write our answers on here. So this was -2 and 0, and that was 4 and 0, and that was 1 and 18. Okay, now the trick always is to read things carefully. In question 5.4, it tells us the graph of h of x equals f x plus p plus q, and it has a maximum value of 15 at x equals 2. What does that mean? Well, first of all, what is the first bit? What are they trying to insinuate has happened over here? What does this imply that I'm highlighting in green? What's happened? How has f been changed? Any ideas? So by writing f of x plus p plus q, what are they implying has been changed or done to f? I thought that too, Johannes, when I first read it, but it's actually not. It's not written in turning point form. Okay. It's very easy to get confused. All right, I also thought it had been written in turning point form, but that's not what they're implying. Yes, Buhle, it's been shifted, it's been translated. So what we see there on the right-hand side, equals f of x plus p plus q, is not turning point form. They are implying that a translation has taken place, and that is the rule for translation. So they are telling us plus p implies that f of x has been shifted either to the left or to the right, and q implies that it has either been shifted up or down. Okay, so now that we know that they're talking about a translation and that this represents a rule for translation, let's look at the other information that has been given to us. They've told us that it has a maximum of 15 at x equals 2. Well, what does that mean for us, Matrix? What are they telling us by saying it has a maximum of 15 at x equals 2? What information are they giving us? Can anybody tell me? Sure, x and y values where? Specifically where, Buhle? At a specific point. Where?
Ma'am, is it the turning point?
The turning point of the new graph, absolutely. Okay, very nice, well done. So what we see here, Matrix, in question 5.4 is this, okay? As far as our graph of f is concerned, its turning point is at 1 and 18. As far as our graph of h is concerned, its turning point is at 2 and 15. So now we say to ourselves, we need to write a rule for translation, okay? Because that's what this represents. This is a rule for translation, so that we can shift f in order to obtain h. So we see the turning point has changed from 1 to 2, and f has changed, the maximum has changed from 18 to 15. What does P represent? Does P represent the change in X, or is P the change in the Y?
The change in X.
In change in X, absolutely. It's the change in X. So if my turning point was at 1, where X is equal to 1 before, and now it's at 2, what have I done to my graph? I've shifted it 1 unit to the
Left.
Okay, so I've gone from F to H. F to H. So what have I done? I've shifted it 1 unit to the?
Right.
Absolutely. And how many units up or down? Remember, I'm going from F to H. F is my starting point, H is my ending point. So I've shifted 1 to the right and?
Down.
How many down, Cassandra?
3.
3 down. Okay, now for the tricky part. Now I have to write my rule for translation. So if I want to translate f of x to get h of x, am I going to write +1 in here, or am I going to write -1?
Minus.
Yeah, that's right, Kamisile, because I am writing a rule for translation. Okay, so if I want to shift it 1 to the right, I have to sub in -1. And then as far as me shifting it down, this would be -3. Absolutely. So therefore, the values of P and Q, Matrix, P is equal to -1 and Q is equal to -3. Okay. All right, well done, guys. That was really well done. I thought this was going to fox you, but it didn't. Excellent. Well done. That's brilliant. Everybody happy? Can we move on? Any questions? Are we all okay?
Yes, ma'am.
All right. So I don't know if you're getting the hang of this now, but really what you need to do with each question is figure out, what does it mean? What are they asking you? And once you know that, you can answer the question. Okay, anyway, well, that's what I'm trying to help you understand anyway. Okay, now 5.5, this is, well, it's this one and the next one is the reason why I chose this question. Determine the equation of g to the minus 1, the inverse of g in the form y equals. So now again, I'm going to give you some quiet time. I think this is worth 3 marks. Let me just double check. Oh, it's worth 2 marks. I want you guys to do 5.5 on your own. This should be quite easy. It's the inverse of g, not the inverse of f. Okay, the inverse of g. Okay, so in other words, it's this one over here that I'm highlighting in turquoise. So determine the inverse of that, please, matrix, and then we'll do 5.6 and 5.7 together. Cool. Nice one. And Johannes has even given us an answer. Cassandra, can you see there? Did you get the same answer as Johannes?
Ma'am, I didn't.
You didn't, Cassandra. Okay.
Yes, ma'am.
That's okay. What did you get, Cassandra?
I got 1 over 2x minus 2 is equals to y.
So like that. Is that what you got?
Yes, ma'am.
What I've just written on the screen now.
Yes, ma'am.
Okay. All right. So in other words, where Johannes has got +2, you've got -2.
Yes, ma'am.
All right. That's fine. Okay. So let's have a look and see who's correct here. All right, 5.5. So the first thing that we would have had to do, matrix, obviously, is switch x and y around. So if they've given us y equals 2x plus 4, we would say that x equals 2y plus 4. So now if I leave 2y on the right and I take the 4 over to the other side, it's going to be x minus 4. And then when I divide through by 2, I'm going to end up with y equals 1 over 2x minus 2. Okay, so Johannes, it was just simply a little, when you took the 4 over to the other side, I think you forgot to change the sign. Okay, but not a big thing, but just, it's funny how if we're going to make mistakes, it's with signs and stuff like that. Okay, so everybody else, who else got it right? Promeza and Shyama, well done, very nice, good stuff. Okay, so that's only out of 2 marks. Let's move on. Now here again is one of these level 3 kinds of analysis, interpretation, well done, can you see there, sorts of questions. So for which value or values of x will g to the minus 1x times g to the x equals 0? Okay, so instead of me telling you, I want you to tell me, matrix, what does that mean? Can anyone tell me? Are you guys like so exhausted? Just tell us, Lee. We don't want to have to think this one through for ourselves. Is that the stage we've got to? Shame, I'm sure. Everywhere else, the matrix are all having a break and we're sitting here working, but it will be worth our while in the end. Okay, so I'm going to try and relate it to something that you already know. Okay, if I said to you, for which values of x is x minus 2 times x plus 3 equal to 0? For which values of x is that true? What would you tell me then?
2 and minus 3.
Absolutely. So you would say to me, where x is equal to 2 or where x is equal to negative 3, 100%. Exactly. So for what value of x will the two graphs multiplied be 0? Beautiful, Johannes. I could not have said it better. All right. So essentially what we're doing here is we're saying, well, either where the 1 is 0 or where the other one is 0, isn't it? So the line that I haven't written, the thing that we learn in grade 10 or grade 9 or whatever it is that's where x minus 2 is 0 or where x plus 3 is 0. This means exactly the same thing. So where is the inverse 0 and where is the or where is the original 0 at the same time? So now I'm going to go back and I'm going to go to the graph over here. Where would that be? So remember your inverse, I'll just write down the equation for you here. So g of x is 2x plus 4, and the inverse was half x minus 2.
Ma'am,
Yes, Cassandra.
is it x is equals to 4 and x is equals to minus 2?
It is. It is. Good job. Well done. Okay. Nice. Well done. So either where x is equal to negative 2 or it's equal to 4. All right. Nice one. Well done, Cassandra. Okay. So those are at their x-intercepts. Okay. So where x is equal to negative 2 is going to be the x-intercept of this graph, which is already sketched for us. This other graph is going to have an x-intercept at 4. Okay, so where are both of them, where are their y's equal to 0? So that's exactly it. Okay, well done, Cassandra. Lovely answer. Is everybody else okay with that? I hope I've explained that sufficiently. Now for the difficult question. Question 5.7. Well, that's not really that difficult. Let me move this over a little bit. All right, so here we are asked, if P of x equals f of x plus k, determine the values of k for which P and G will not intersect. So what do we do here, Matrix? How would we attack this question? Any ideas? Where would we start with this, and what are they expecting us to use to get our answer? Do you all feel blank about this one?
Ma'am,
Cassandra.
can we use type of roots whereby we're going to add k on f of x and start solving for k?
Absolutely. Absolutely. Well done. 100%. Okay, so you're going to use nature of roots to answer this question, and they want an algebraic solution because they've made it out of 5 marks. So it's not something that we can just read off the graph. Okay, so when they tell us that P and G will not intersect, what kind of roots are they asking us to solve for? What sort of roots are those? Where two graphs do not intersect one another, they have what sort of roots? Matrix?
Negative roots.
They have non-real roots. They have non-real roots. Okay, so delta is negative. You're on the right track. Okay, so let me just move these ones down a little bit. And let's just go back over this because this is important for matric. This is something that definitely could be asked. Okay, do you remember in grade 11 you had done nature of roots, and what you found is that either roots could be real or roots could be non-real. Now, when roots are non-real, what that means for you is that your parabola does not intersect another line, okay, or does not intersect the x-axis. Okay, so in other words, the two don't touch one another. The shape of the parabola is unimportant. What's important here is that this line over here and the parabola don't touch one another. So in other words, if we tried to solve for x for a point of intersection, we wouldn't be able to do that. All right, so inside our square root, we would end up with some negative number, which meant that the roots were non-real. Okay, so that's essentially what we're looking for. So when roots are non-real, delta is smaller than 0. So that which is inside our root, in other words, b squared minus 4ac, has to be smaller than 0. Is this ringing a bell now? All right, so you need to do a solution for k based on non-real roots. Okay, so what Cassandra said about adding k on to f of x is correct. So f of x is minus 2x squared. So we've got minus, come pen, minus 2x squared plus 4x plus 8, if I remember correctly. Oh, plus 16. Okay, that would have been a bit of a disaster. We'd written down the wrong thing. Plus 16. And k is added to that. Oh, there we go. Okay, Pumeza, we'll have a look at your answer now. All right, so they've added k onto that. So now we need to solve, because it's in standard form, now we need to solve for where, so for non-real roots, delta is smaller than 0. So we need to solve b squared minus 4ac smaller than 0. So now when we sub in b squared, that's going to be 4 squared. Remember, b is the coefficient of the x term. Minus 4 times a is negative 2, and c in this case is everything else. So that's going to be 16 plus k smaller than 0. Okay, so now we need to remove our brackets and collect our k term one side and our number term the other side. So this gives us 16. I agree, Pumeza. Negative 4 times negative 2 times 16 is going to be 16 times 16, which is going to be plus, is it 256? Nicole? Is that right? Let me just double check. Yeah, 256 is correct. Okay, plus 256. And then we've got negative 4 times negative 2 times positive k, which gives us plus 8. K is smaller than 0. Okay, so leave the k on the left. Take the numbers over to the right-hand side. So if we add 16 to 256, we're going to end up with 16 and 256 is 272. So that's minus 272, and then when we divide both sides by 8, k is going to be smaller than, have I done something wrong here? No, okay, no, that's negative, sorry, ooh, silly me. Negative 12, comma 5. Okay, no, we haven't done anything wrong. Okay, perfect. Everybody happy with that?
Ma'am, I have a question.
Sure, can you see, Leigh?
Ma'am, where did we get the 256? I'm confused. I'm lost.
That's fine. So what I'm doing is this, Can you see there? Okay. Imagine, so it's this line here that I'm highlighting in blue that I'm working with. Okay. So there's the first term. There's the first term. Now to get this term over here, I've got to multiply together -4 with -2 with 16. So in other words, if I have -4 times -2, and then in brackets, I've got 16 plus k, what I can do if I want to is I can multiply these two numbers together first, and I can say that that's 8 times 16 plus k. So 8 times 16, that's where the 256 came from, plus the 8k. I'm just expanding my brackets. Does that make sense?
I keep getting 128.
Yes.
Sorry, have I done something? Have I made a mistake?
I think so, ma'am, because we keep
Okay.
getting 128.
You keep getting?
128.
When you multiply 16 and 16, sorry, 8 and 16 together. Oh, sorry. You're quite right. Sorry, I'm being stupid here. I know what I've done wrong. I said 16 times 16. Sorry, this is 8 times 16. Yes,
Yeah, it's
sorry,
128.
sorry. Yes, quite right. 128. Okay, so now hang on a second. I think the answer was correct. So we've got 16 and 128, which gives us 144. Okay, that's better. So over here we've got negative 144, and then if we divide negative 144 by 8, I think it is -12.5.
It's 18.
Is it? Is it 18?
-18, yes, ma'am.
Okay, I've done something wrong then. Hang on a second.
Oh, mente.
What did I do? I see my mistake. Sorry.
Ma?
I see what I've done wrong now. Okay, so sorry, what we were supposed to do, we added the k to the graph, but what we forgot to equate it to was the straight line. Sorry, that was stupid of me, because it said here that it would be for which values of k will p and g not intersect. So stupid me, I left off g. Does that make sense to everybody?
Yes, ma'am.
Do you understand what I've done wrong? Okay, so I did for which I calculated the values of k for which f of x and k will not intersect. I'm sorry, my apologies there. I forgot about g. Okay, which was silly of me. So here it should have been equal to, beg your pardon, this should be 2x plus 4. So everything else that we did was correct. Obviously, it's just we would have had to get this into standard form first. All right, so that would have given us minus 2x squared plus 2x plus 12 plus k equals 0. Sorry, so now when we sub into delta, see what happens when you guys don't read the questions properly. Even me, I'm guilty of it sometimes. Okay, so b squared, so that would be 2 squared minus 4 times a is minus 2, c is 12 minus k is smaller than 0. Okay, so this gives us 4 minus 8 times 12 now. 8 times 12 is 96.
Ma'am, plus k, not minus k. She made a mistake.
There we go. Sorry, I'm rushing now. Beg your pardon. Okay, that's correct now, isn't it? It's 4. Then 8 times 12 is 96. So that, sorry, that should be positive 96. Plus 8k is smaller than 0. Okay, so that gives us 100 plus 8k is smaller than 0. So 8k is smaller than negative 100. Divide both sides by positive 8, and then indeed k will be smaller than 12.5. Okay, so sorry, I was stupid here because it said we needed to first of all add k onto f of x, and then for f and g determine which values of k they will not intersect. All right, there we go. No, sorry, Promesa. Everybody happy?
Yes, ma'am.
You sure? I haven't confused you.
Yes, ma'am.
Okay. All right. Because I would hate to make it worse. I don't want to make it worse. I want to make it better. So sorry. There you go. See what happens when we rush and we don't read questions properly. So even us teachers are guilty of that at some stage. Okay, is that all right, everyone? Any questions? Okay, so tonight is quiz night. So if you can, please go and do the quiz. We'll look at the answers next week as well. I'm sure that Nicole will put the link, oh, there, she's done it already, the link to the quiz in the chat. And thank you very much, Matrix, and I hope you have a lovely long weekend. Thank you, Nicole.